always great to be the speaker between you and lunch. And the introduction from him was, "Hey, get down quickly." Sounded like that, but hopefully, this will be interesting enough that your appetite will be better for lunch. Okay. So today I'm going to talk to you a little bit about charting your path, right, to fault-tolerant computing. And this is really not quantum-centric supercomputing. I would actually just call it computing at the moment. Okay. A little bit about Quantinuum. Like I said, it's been 9 months since I joined Quantinuum. It's one of the largest quantum computing companies, 500 plus employees, 375 plus scientists, PhDs. We have locations across the US, UK, Germany, and Japan. I didn't know the magnitude of the people and the quality of the people that I was going to work with when I joined the company. Okay, so this has been a revelation, and even the commercial team is fitted with PhDs, who know what they're talking about when it comes to computing. Okay, so very proud of the company, excellent cross-domain subject matter expertise, and in going back to Yuval's question during the panel, right? What was really impressive for my company in the last uh, 9 months since I was there, is what I'm going to be talking about later today. So we made some announcements today. Also, I'll talk to you a little about it at the end of the day. This stack is something that people who are in the supercomputing space, in the HPC space, are probably very familiar with. Okay, so our job, right, is to make the stack open, accessible to customers, and continue to innovate in the stack. Some of them are open source, as you probably know. A lot of the people here use TKit. It's a high-performance software development kit. We make sure that this TKit is actually working on multiple backends. Okay? Of course, we'll continue to innovate on our own hardware. But if you look at the top level stack, we have a lot of software packages that we offer. Okay. One of them is in the chemistry space, which is in Quanto. We have several key customers using it. I'll go through some of the customers who use this at the end of the talk. We have some applied algorithm expertise. We have QML libraries. We have the only software product, right, which comes out of a quantum computer today that we call Quantum Origin. Okay. It is the only provable random source, okay, available today. And soon you're going to see it in multiple firewall vendors. Okay, today's entropy that you're using in your phone, in your laptop, all of them are pseudo-random in nature. When you're developing those keys, which is used in the RSA protocol today, and your AES key generation. And today, we'll also be having an announcement on Nexus. I'll talk to you a little bit about Nexus later as I go through the presentation. Let's talk about, again, you all set me up, I think, unknowingly. But what is really the backbone of what we do, other than our software stuff, is our H-series computers. Okay. It is the highest performing, highest fidelity machine. We've got 2-qubit gate fidelity at 3 nines. I'm learning, what fidelity and how you measure fidelity. I'm finding out that it is not as standard as it is in the classical space. And then we've used quantum volume. We are the #1 quantum volume in the world. We are at 1 million. The second is at 512. I also noticed, coming from the classical space, that when I first joined, a lot of people were talking about quantum volume, and then people just stopped talking about quantum volume, and that perplexed me a little bit. We are the most benchmarked. We have about 18 benchmarks tested. We report all of that in GitHub, and we have some leading features which allow you to do some interesting stuff. I'm still learning a lot about what it enables. We have conditional logic, all-to-all connectivity, mid-circuit measurement, which actually allows you to do very interesting quantum error correction protocols. Right, so this is something that is very interesting. We have all of these published, 18 benchmarks, which are published. We use the randomized circuit bench, RCS for 2-qubit benchmarking when we report our fidelities. We just don't do 2 qubits. We do every pair of 2 qubits in our system. And, so what is something that I'm seeing is when you're in the classical space, you kind of know spec FP, LinPack, streams. That's how you measure your system, and everybody adheres to it. Right? Here, I think it is a little bit as expected. It's an infant space, but standardized benchmarking is going to be very important to actually determine what your system is doing. Okay, so this is something that I think the whole industry needs to work on to get to something that actually determines, what correctness is. Otherwise, everybody's going to say something, and it's going to be tough to believe it or not. Okay, so let's talk about Nexus. Today, we announced a beta program, right? Where you can actually go to our website and you can access this piece of software we call Nexus. We're moving forward in terms of how people can use our system. Okay, Nexus is a single platform which will allow you to access our system, access our software, and make it very, very easy for users to use our platform. Okay, so if you're interested in the beta program, you can basically go to our website and have more information about Nexus. So this is a high-level look at it. Using our platform, you'll be able to access simulators, you'll be able to access our backends, access our software and other people's backends and other people's software also. Okay? Today, it is not such an easy task. Okay? Today, we are like in the VI days. How many of you, put your hands up if you remember VI and Emacs? Awesome. Okay, so we are moving it a little bit more. I don't know how many of folks are used to some of these tools like Eclipse and stuff like that, which came from IBM. But we're moving more into this area where it's easier to start using quantum systems, and it is going to be a journey. Okay. So you can register your interest if you want to take a shot of this. You'll also have a copy of these slides. If you're interested in using it, please use this QR code. This is something that I was very impressed when I, got into Quantinuum. Today, if you look in the GPU space, okay, there's really no one standard which will allow you to use multiple GPUs. Okay, people like Intel have tried to do one API. AMD has tried to do, I think they call it ROCm. But there's really no one standard which allows you to use GPUs. TCAT is an open source library, right, which allows you to take multiple inputs, whether it be in Qiskit, Cirq, QIR, and convert it and use it for any backend. And it's completely open source. Okay, this is very important for the quantum computing industry, right? From a Quantinuum standpoint, right, we are very, very open, right, to make sure that software works on multiple hardware and vice versa. As far as how you can access our system today, if you're in the US, you can, oh, I didn't do that. Okay. You can start with Oak Ridge. There's a program where you can apply for time on our system. You can go directly to Microsoft Azure, and you can come in through Azure Conto. You can actually get in Quanto, and then as part of it, you can have access to our system. And then you can start directly with direct access to us, which is kind of what Oak Ridge does, right? So we have corporates who have direct access to us, and some of the corporates use up a lot of our time. So going into Quantinuum, I haven't been able to keep up in the last 9 months in terms of the types of innovation which is happening, and the announcements which have been done. So just want to give you a quick idea of some of the recent milestones that we have since I joined. The first one is Recon. We're extremely proud of it. I'll have another slide which shows it. Recon selected Quantinuum Model H1 for a hybrid quantum supercomputing platform today. A lot of people have been talking about hybrid quantum supercomputers, right? But it is very, very important, okay, to build that software infrastructure which actually talks. Okay? When I was doing my thesis in the 80s, I had to build my own networking library. Okay? Today you have something called MPI. But in those days, everybody had to go and develop their own processing communication library. Okay? And with this work, with Recon, they will have open standard libraries which will enable quantum computing, hybrid quantum, and classical computing. And having standards there is super important. Everybody else will be wasting their time building these interfaces. Excellent work being done there by Recon. Then we announced the 3 nines, which I think was the first 3 nines achievement on our H1 system. That's why I was most impressed with is the high fidelity, that we are, making progress every year, every month actually. Okay. And the announcement with Microsoft was huge. They actually showed 800x improvement. Okay, it was about 10 minus 5. And we'll talk a little bit more tomorrow with Microsoft on that announcement and what that enabled from a logical qubit standpoint. Okay? And that is very important to the progress that you have to have. Everybody thinks you're going to have an application working tomorrow. It is a journey. Okay? We have to start the journey today on real applications to get to, I don't like the word quantum advantage. I don't like the word quantum supremacy. You have to get to a point where the application brings benefit to the customer. Okay? And that is really the path that we have to go through. And we also made an announcement on our H2 system where we have taken it to 56 qubits. Today, this is a machine that cannot be simulated. A huge achievement in the industry. We also had some work where we worked with JP Morgan on RCS, and there was a huge, huge improvement in performance compared to previous results, which were published by other people in this field. The last one on the bottom right is an important aspect. People have always been saying, you know what, trapped ions don't scale. Okay, and we have an architecture with H3 where we actually solve 2 problems. One is the scaling problem and the wiring problem. People don't talk about it. Once you get to million qubits, imagine the number of wires going into your quantum computer, let alone how you debug the system. Okay? Lots of work needs to be done in that age. And we have solved some of those problems. We'll continue to work on the software side. Imagine writing a piece of software for 1 million qubits and debugging it. Lots of work needs to be done. Microsoft, huge achievement. We've been extremely proud of the work we're doing with Microsoft. We had an 800x improvement in fidelities. As you can see, we went from 10 minus 2 to 10 minus 5. 5 nines on this particular example. Okay? It'll change based on the applications. This particular example, we got to 5 nines and logical qubits. 14,000 experiments without errors. We'll talk a little bit more about it tomorrow. This is what excites me about quantum computing. Okay? If you have seen some of the papers this week, you'll see people saying, you know what, I need 100,000 logical qubits to do something in chemistry for something useful. I can't even play golf by the time that happens, I think, right? Okay, so the approach that Microsoft has presented, right, where there's a combination of HPC, AI, and quantum, is going to enable usage in the commercial area much earlier than we think it's going to happen. Okay? And that is going to be a huge part of what is necessary, to have commercial advantage in computing today. Okay, just quantum computing alone, with what all the results and all the projections that you have, is going to take some time. Okay, but with this combination of approach, I think you're going to have earlier advantage in a commercial standpoint. We'll talk a little bit more about it tomorrow when Microsoft comes on stage. And we're opening up new frontiers, right? You probably heard about, hey, you know what? We can take a pipeline for AI. I spent all my life on two things, HPC and AI. Okay, and AI is a power-hungry monster. It's expensive too. Lots of research is being done to see if you can take the pipeline, the AI pipeline, whether it be for variable autoencoders, right, the stuff that you do in Stable Diffusion, for example, uh, or for something which is in a large information model or large language model, as people call it, and use quantum computing in there. It's very infant at the moment. We have published some papers, okay, where we actually have taken the variable autoencoder pipeline and replaced it with some quantum effects. Now, again, it is not for, it's not for real world application. It's for a small set of data. Lots of work needs to be done in that space. We also had some work that we did with DeepMind, where we've used AI for quantum. And I think those are table stakes. I call them table stakes, which is you have to look to see how you use AI, whether it's in quantum error correction, quantum error mitigation. And in our case, we used it with uh, Google DeepMind to reduce the number of T-gates in your software. Okay, so this, all right, a little bit of animation. We're working across the world in collaborating with leaders in the computing world to advance quantum computing. And we're all doing it together, right? I think you saw a lot of people here today. IBM talked about it, QI talked about it. And it's a journey. We're all going to be together. This is Quantinuum's journey. Okay? We have the RIKEN integration with the Fugaku computer we talked about. We're going to collaborate on a hybrid compute infrastructure and use cases. The key here is to get that hybrid HPC quantum computer, the software stack, available in a standardized form so we can reuse it. Okay? You don't want to be in the place I was in '88 where I had to go build my own MPI libraries. We have a big team here in Japan. Shuya-san is our CEO. He's sitting over there in Japan, and we're very proud of the work we're doing with RIKEN, as I mentioned earlier in the panel. Okay. The other announcement we had last week was we published an MOU with Hartree, okay, where we're going to be working with them on dedicated access, research, outreach to industries, and we are extrememely proud of the engagement here in Hartree. This is right in the heart of our like we said, I haven't mentioned this, but we were a combination of Cambridge Quantum, which came out of the UK, and Honeywell Quantum Systems out of the US. Super proud of what we established in the UK. Okay, and this was announced today. We just announced an MOU with Singapore. It's with the Singapore's National Quantum Office, A-Star, National University of Singapore, and National Supercomputing Center. And this collaboration is going to be driving applications in computational biology and other quantum accelerated high performance computing application. Extremely proud of what we did today, and it'll pave the way for new roadmaps, joint roadmaps, and like I said, for quantum computing to move forward, you need to have computing in the hands of researchers. Okay? And we need many, many systems, right? This is just one of many that is needed around the world. How am I doing on time? Is there a timer? Okay. And I know I've kept it for the last, but our partnership with Mitsui, not only as an investor but as a business partner, is super important for Japan, for our company, and the region. Okay, we are super proud of the joint development. We're going to be working on joint development of use cases, uh, market development, sharing of quantum computing knowledge. Please visit our booth, and we will have more information about how Quantinuum and Mitsui can work with you here. Last but not the least, this is a journey. I wanted to end with this slide. This is a very important slide. Okay, people are not going to have quantum computing applications overnight, suddenly working. Even if you had like a million qubits, you need to start the journey today. These are some of the examples that we're working with who are investing in the long journey with us. Some examples: BMW, we're working on hydrogen fuel cells. Amgen, who happens to be an investor also, we are using some of our innovative compositional AI techniques we call quantum natural language processing for peptide binding. This is a journey, and companies need to start today, and all of you are part of it, right? So let's all work together, and I'm excited, that all of you actually attended the whole thing without going to lunch, and we'll see more of these. But be aware. I think we'll all have to be aware. This is a journey. This is not. You're not going to have a product overnight from these folks, right? They're going to participate in the journey, and at some point, you're going to have the software ready and the hardware ready to enable real applications. Thank you.